Hey, good morning everyone. Good morning class. How are you all doing? Welcome to the class, बच्चों. Welcome. Oh, ये क्या हो रहा है यार? तो asking for Insta ID kind of thing. यहाँ भी तुम दोस्ती कर लो. सब दोस्ती कर लो तुम लोग. Good morning everyone. Good morning. And I hope you are revising things. Huh? So you are having a test on Sunday. That means tomorrow. Are you well prepared for that? Okay, great. Like say the syllabus for the test, I'm announcing it. I mean right now. It is basically whatever we have done from day one. It will be coming and till Planck's quantum theory. But black body radiations won't be given this time. They will be coming next week. Okay, because of the enormity of the syllabus. So what we have thought is that we'll just cut out one topic that is called black body radiation. Okay, so prepare everything specifically. Boys, do that specific charge, increasing, decreasing order the specific charge upon mass ratio. Do that quantization of charge as well. Do electromagnetic radiations, that C is equal to lambda into frequency. Okay, isotopes, isotones, isobars, all those questions, just do that. Average atomic mass, all that we have done, just revise it thoroughly. Okay. Okay, and yes, obviously few questions on Rutherford and Thomson model also, which we can do that. And today we'll be beginning with Planck's quantum theory. है ना? Black body radiation we'll do next time, boys and girls. Okay, चलो ठीक है. So now we do Planck's quantum theory. Planck's quantum theory. Okay, so we'll do first one thing. We'll first write down the postulates given by the Planck. Okay, so please write down postulates. I'll explain them again. Okay. Achha, what do you mean by postulates? Like when someone gives postulates, it means he is believing those things, but he does not have enough proof to prove that stuff. He does not have any mathematical derivation for whatever equation they are giving. There is no experimental backup for what they are saying as such. Okay. So, but this is how the science progresses. You are going into the unknown territory. You simply do not know what lies there. So you begin by saying certain things which you believe are right on the basis of what you have been through in the past. Yes or no? Like you also say that if that person is like looking a bit rude kind of thing, so maybe he's normally angry. So this is how we believe, and we carry on in the world society by believing in what we have been through in the past. Hypothetical things, normally hypothetical things, but more informed. This is called intelligent hypothesis. Okay. So first postulate he gave was that, please write down, any white glowing object, any white glowing body, any white glowing body will emit all radiations in equal amount. Will emit all radiations in equal amount. All radiations in equal amount. Now see that. Achha, what is white light? By the way, what is white light? It is basically combination basically of entire thing called Vibgyor. Yes or no? Entire thing called Vibgyor. Agree or not? So when all these colors basically are combined in equal amount, they will produce what? A white light. Will produce a white light. So this is what he was saying that, and it was okay with that. There was no problem with that. Second and very important one, all electromagnetic radiations they occur due to I told you, remember that, acceleration or vibration, acceleration or vibration of charged particles. All electromagnetic radiations, they occur because of what? Acceleration or vibration of charged particles. But I told you that if an electron, for example, is moving, if it is moving, it will emit electromagnetic radiations. It will lose the kinetic energy in the form of electromagnetic radiations. And what are these electromagnetic radiations? All those which we have listed: cosmic rays, gamma rays, X-rays, UV rays, visible light, infrared rays, microwaves, and radio waves. All these are electromagnetic radiations, and they will be emitted whenever a charged particle is accelerating or is vibrating. For example, if there's an electron, it keeps on vibrating. It will also keep on emitting what? Electromagnetic radiation. Yes or no? Write down quickly. At least write down S. Write down S. Done? Okay, good. Very good. Very good. The third postulate he gave was that these radiations carry energy. All these radiations carry energy. All these radiations carry energy. We all know that this X-rays, gamma rays, UV rays, they are all having some energy. All carry energy. And now the very important point. Next point, please write down. These radiations, which radiations? Electromagnetic radiations. These radiations are emitted or absorbed in the form of packets, called quanta, in the form of packets called quanta. So what he was saying is that, very good bache, that if there is any glowing object, it will be emitting, some of the rays will be beta say gamma rays, some will be X-rays, some will be UV rays, and some will be like say visible, some will be like say infrared, maybe we are having say microwaves and say radio waves. So all these are a possibility at a given temperature. Now he was saying that all these radiations will be emitted in the form of packets. There will be a packet of UV ray, there will be a packet of visible ray, a packet of infrared, a packet of X-ray. They will all be emitted or absorbed in form of packet. Yes or no? In the form of packets called quanta, or say single quantum. If one photon or one quanta or one packet is quantum. Okay? Very good. Very good. Okay, now what I'm saying, next one. Now energy, which actually means what? That they are emitted. If like say there is a body, it will emit one photon, next one more photon. Are you getting it? And next one more photon. So the photons, or say quanta, will be emitted discontinuously. Yes or no? Energy will be emitted or absorbed discontinuously and not continuously. Please write down. The meaning of this thing is what? That energy is emitted or absorbed discontinuously. Energy is emitted or absorbed discontinuously. These are very, very important points. If there is a body which will be absorbing the photons or say quantums, they will be absorbed in the form of packets. One packet goes inside, then will come next packet and third packet, like that. And they will be emitting also in form of packet. One packet gone, then next packet coming up, then next packet going outside. That means energy is not continuous. Earlier people used to believe that all these radiations are emitted continuously. But he was saying no, they will be emitted discontinuously. Are you getting it? It will be emitted discontinuously. And he said that energy of each packet, write down, next point, energy of each packet, be quick. Energy of each packet is proportional to the frequency, of the charged particles, the frequency at which it is vibrating. If the electron, say for example a charged particle, is vibrating at very high frequency, the frequency is very high, and there is electron which is vibrating very, very slowly, so frequency is low. But who will tell me if this frequency is very high and this frequency of vibration of electron is low? Tell me one thing, in which of these, first or second case, you believe gamma ray will be emitted, and in which case radio wave will be emitted. In which case gamma ray will be emitted, and in which case radio wave will be emitted. Here the electron is vibrating at very high frequency, and here at slow frequency. Frequency is low. I want everyone to answer that. Very good. Very, very good. Sharanya, beta, please check your answer. Oh, ये कौन भैया ये? Sorry, bro gaming. No. Check your answer. हाँ, ठीक है. This will be beta gamma ray, because we know that in that electromagnetic spectrum, gamma ray, X-ray, UV ray, visible ray, infrared ray, microwave, and then radio wave. So over here, frequency, if I talk about frequency, keeps on decreasing as you go from left to right. Highest frequencies of gamma ray and lowest is of radio waves. So first will be gamma, second will be radio waves. Yes or no, Gudia? Everyone getting that or not? So if a charged particle is vibrating, at very high frequency, it will emit what? Probably an electromagnetic radiation of high frequency. But if they are vibrating slowly at low frequency, they will emit a vibration, electromagnetic radiation of low frequency, maybe micro, maybe radio. Yes or no? So this is how the electromagnetic radiations are emitted. They depend on what? Vibrational frequency of charged particle. Getting it, everyone, now? Sure about it? So you can keep on noting these things down. Acha, aa jao now. Now I'm saying that energy of the photon or the quanta emitted is proportional to what? Frequency. And I know that in all electromagnetic radiations, C is equal to frequency into lambda, which means what? Frequency is what? C upon lambda. From here, can I say that frequency is inversely proportional to lambda? Can I say that? Which also means that if frequency is higher, obviously lambda will be lower. Hello? Over here, Planck was saying that energy is proportional to frequency, which actually means energy is proportional to frequency and frequency is inversely proportional to lambda. So can I say from here safely that if energy emitted is of higher level, which means frequency will be also higher, and which means what? Lambda will be lower. Agree or not, bhai? Bolo bachcho hai. Agree or not? Gamma is a lower wavelength, no doubt, beta. But we are talking about the frequency part. Okay, so now the next point, he said energy is proportional to frequency or proportional to what? 1 upon lambda. From here we can say energy is equal to h nu or equal to what? hc upon lambda. Yes or no? Can I write that down? Gamma has a higher frequency. Very good. So E equal to h nu. And what is this? And what is this h? This is the energy of one packet. This is the energy of one packet. Energy of one packet. So h is called Planck's constant. Planck's constant. And this value is actually 6.626 10 to power of minus 34 joule second. Please beta make sure that you are writing the units properly. 6.6 10 to power of minus 34 joule. Yes, very good, bachcho. Very good. Energy of one packet. Very good, bachche. Very, very good. Is that clear to all of you? This is very important, bachcho. This is going to follow in black body radiation and in photoelectric effect also. Probably this will become the part of the entire atomic structure now. Wherever you go, you will find this stuff. Shall we move ahead now? Okay, chalo aa jao. Okay, come. So energy, what I'm saying, suppose there is a body which is emitting photon of say energy say 2 joule. One more photon will be emitted at say 2 joule. One more at say 2 joule. Energy of each is what? 2 joule. So total energy emitted how much? If there are 3 photons or 3 quantums emitted, what will be basically the energy, total energy emitted? 6. So what you're doing? You're doing 3 into 2. Again, and if there are supposed to 10 such packets, if we have got 10 such packets, each containing 2 joule, so total energy will be how much? Total energy will be 10 into 2. This 2 is what? This 2 is nothing but h nu, the energy of one photon. This is nothing but h nu. Yes or no? So can I say that next point please? Total energy emitted or absorbed. Total energy emitted or absorbed will be equal to what? N, h nu. If n is the number of quanta emitted or quantums emitted, equal to what? N hc upon lambda, where h nu is the energy of one quanta or quantum and hc upon lambda is the energy of one quantum. If there are say n number of quanta being emitted, total energy will be n h nu or n hc upon lambda. Yes or no? Where this n value is what? 1, 2, 3, 4 and so on. That means it will be a positive integer only. It will be natural number. Hello? Acha, where have you seen this thing? Where have you seen this thing before? Something like that. Remember that? Somewhere? Millikan's oil drop experiment. Very good. He's told that the charge will exist in the form of what? Integral multiple of 1.6 10 to the power of minus 19 coulomb. Yes or no? Where n was what? 1, 2, 3 and so on. He was saying that charge is quantized. Charge is quantized, and here Planck is saying that energy is also quantized. Energy is also quantized. Well, n will be 1, 2, 3 and 4. Yes or no? So here this means energy is quantized. When I say something is quantized, it means that not every value of energy or charge is possible. Only certain values are allowed. Only certain values are allowed. Are you getting it? So what I'm saying over here, is it possible to have a value of charge equal to say, maybe say 2.1 10 to the power of minus 19 coulomb? Is it possible? Is it allowed? No, it's not allowed. Because I mean, if the least value is 1.6 10 to the power minus 19 coulomb, next higher value will be 3.2 10 to the power minus 19 coulomb multiplied by 2. Similarly, I'm saying that if this body is emitting a photon of say 2 joule, next will also be like say 2 joule. Yes or no? So will ever it be possible that this body is radiating an energy of 3 joule? Will it be possible? Every quanta it is emitting has an energy of 2 joule. In that case, it cannot emit 3 joule, 5 joule, 3.2 joule, or 3.7 joule, or 5.8 joule. Only possible values are what? Multiple of 2 joule, integral multiple of 2 joule. 2, next higher value will be 4, then 6, and so on. Is that clear? Is that clear? Yes or no? Ha. Integer value is only possible, but of n only. Hai na? Good one. Very good. Very good. Very good. Okay, now. Achha, now see that stuff. What Planck was telling was that energy is quantized only at the surface. Energy is quantized only at the surface. That means energy will be absorbed in the form of packets or will be emitted in the form of packets. Absorbed or emitted in the form of packets. But this energy which is being emitted will be propagated in the form of wave. Will be propagated in the form of wave. Yes or no? This quantization is occurring only at the surface of the body. It will be absorbing or emitting in the form of packets. But once it is done, the energy will be moving in the form of wave. Yes or no? Please write down the statement, please. This emitted energy or in bracket EMR, emitted energy in bracket write down EMR is propagated in the form of wave. Is propagated in the form of wave. Is propagated in the form of wave. That means what? And wave is what? Continuous. Continuously is propagated in the form of waves, that is continuously. Yes or no? Is that clear? All of that? Good one. Brilliant. Very good, bachcho. Excellent. I hope that you have learned certain thing new today. The basics of what that stuff is that. Because when you read it basically from NCERT, the things may not be very clear. They're a bit confusing kind of thing. Okay? Good one. Very good. So like it's time to solve some numericals. So can I share some tricks with you to how to handle the numericals now? See that stuff. You know that E is equal to hc upon lambda, where h is what? 6.626 into 10 to power of minus 34 joule second, and c is what? C is 3 into 10 to power of 8 meter per second. Now this is also a constant and c is also a constant. Both are constant. So constant into constant will give you one more constant, and this value is reading NCERT in physical chemistry is important. Yes, but it is important now everywhere. So please read the NCERT, bachche. Please read it properly. And it's very, very important. So HC will be 2 into 10 to power of minus 25. Please learn this value. Learn this value because this will be coming everywhere now. Everywhere. You know, photoelectric effect, it will be like, say, kinetic energy equal to what? Hc upon lambda minus 5. So there also you will come across Hc. So why to multiply every time these values? We will learn that stuff. Sriram, like, see, this doubt is like there. Sriram is asking that just now you said discontinuously emitted. I am saying, beta, that it will be emitted discontinuously after packet, but once it is emitted, it will move in the form of wave. It will move in the form of wave. The only thing Planck was saying was that energy will be emitted or absorbed in the form of packets only. His purpose was to explain black body radiation, and he was done with all the things. He tried all the things, but he was not able to explain the black body radiation by assuming that energy can be absorbed or emitted continuously. He had to make some change into that, a drastic change, for which he was not having any reason. That's why he gave postulates. He said, I believe that energy will be emitted or absorbed in form of packets. But once it is emitted, it will be moving in the form of wave. Are you getting it? Because it will be very difficult for him to fight with basically whom? Maxwell. Maxwell was god of electrodynamics. And he has already told that they are all waves. All of them are waves. Which one? All electromagnetic radiations. Sriram, got it now? Jai Sriram. Okay. Okay. And the wave is continuous. That wave is continuous. Good. Very good. Very good. So where are we? We were here. So we will learn this value. 2 into 10 to the power minus 25. Learn this. Sometimes it is also possible they can ask you, what is the unit of Hc? Unit of Hc. So what is H? H is joule into second. And what is C? It is basically meter per second. Second cancel. This will be joule meter. Are you getting it? But more than that, this value is important for solving questions. Be quick. Be quick. We'll be using that. So immediately you can write down this thing as 2 into 10 to the power of minus 25. Minus 25. Let me write it properly. 10 to the power minus 25 upon lambda. So when you're writing that, your lambda will be in meter, beta. Lambda will be in meter. Be careful because here C is what? Meter per second. So if C is in meter per second, lambda has to be in meter. It cannot be angstrom. Yes or no? Can we? Chalo, aajao. Like one more thing is there. If they give you energy in terms of electron volt, in that case we can write down 12400 upon lambda must be in angstrom. Lambda must be in angstrom. Or you can say that if energy is given in terms of electron volt, I can write down 1240, but lambda now will be in nanometer. Lambda will be in nanometer. So they can give you the option, the answers in electron volt, or they can give you the answers in joule, whatever way. But if they give you joule answer, please make sure that you are able to convert electron volt into joule. 1 electron volt is equal to 1.6 into 10 to power of minus 19 joule. Remember that. Just remember that. Okay? Be quick. So you can choose any method depending on the data given. Yes or no? Agree or not? अरे बोलो बच्चों, अरे आज ही बोलोगे. I mean, Kone, Sheshagiri. I mean, you can write on 1242 or 1240. It's approximate value. In physical chemistry, we can always approach approximately. The options given are very far apart. So there will be no problem. Either you write 1242 or 1240. It's one and same thing, beta. Okay? We do not want Nobel Prize. Do you want Nobel Prize? I want answer in the NEET. Okay? They won't give you +5 marks for doing exact calculations. Are you getting it? I mean, do it roughly, approximately, and that will be true. Okay? Chalo, aa jao. So we'll do the questions one at a time. Okay, come on, tell me. So all these questions will be for electromagnetic radiation, boys, na? And all electromagnetic radiations, they travel with the speed of light, 3 into 10 to the power of 8 meter per second. Yes or no? Achha, one question, boys and girls. Tell you one thing. Who will travel at faster speed? Gamma rays or radio waves? Who travels at faster speed? Gamma rays or radio waves? ये लो, अनन्या जी सो रही हैं. सूर्या, you are sleeping. सुहर्षिता sleeping. ये कौन बोल रहा है गामा गामा? अरे यार, पागल हो तुम लोग. You all gone more mad. I'm telling you. All these electromagnetic radiations, gamma, cosmic, I mean, what is that? X-ray, UV rays, all of that, radio waves, they all move with the same speed. Same speed. देखो लिखा हुआ है ऊपर. You people can't see also. सब अंधे हो रखे हो. Hey boys, tell you one thing. I mean, are you doing the two things at the same time? You're watching the lecture also and you're watching other things also? Playing game also? Huh? Kya? In anywhere, in any medium, if all the EMR are passing, they will pass through same speed. They can have higher frequency, higher wavelength, but speed will be same. They all travel with the same speed. And the speed is what? All of them. Speed of light. Speed of light. Yes or no? Achha, tell me, then how can you give a wrong answer of such a simple question? What? This will happen in the examination hall also. The examiner will play the games with you. You have to be very, very focused. Hello? Achha, who among all these electromagnetic radiation, who will have higher frequency? Who will have higher frequency? Same frequency or different frequency? Cosmic, gamma, X, UV, what? Who will have higher frequency? Cosmic will have higher frequency because from left to right, frequency keeps on decreasing. As you move this way, from left to right, frequency decreases and lambda increases. Good, very good, excellent. Chalo, theek hai, aa jao. Now don't forget this stuff that all EMR travel with the same speed, the speed of light, and all of them. So I'm giving you one question on electromagnetic radiation, and I'm saying that they have given you say lambda equal to 5000 angstrom. You have to find out frequency. Find the frequency of that electromagnetic radiation. Chalo, chalo, chalo. Be quick. Be quick. Time to solve questions. Fastest fingers first. Be quick. Be quick. Come on. Be quick. Jaldi, jaldi. Twarga. What 2.8? What 2.8? 2.8? Lambda is equal to 5000. What 2.8? I'm asking frequency. See that. We all know that C is equal to lambda into frequency. So frequency will be C upon lambda. Agree or not? Now this is in angstrom, while C is like say what? 3 into 10 to power of 8 meter per second. This is meter per second. So lambda must also be in meter. It cannot be basically what? It cannot be angstrom. So we'll convert this into what? Meter, which is equal to 5000 into 10 to power of minus 10 meter. Yes or no? Whenever they give you angstrom, to convert into meter, you will multiply what? 10 to power of minus 10. This will be equal to 5 into 10 to power of minus 7 meter. Yes or no? Now put it there. 5 into 10 to power of minus 7 meter. So meter will cancel out. Meter will cancel out, and we will get this thing. But I mean, can I take this 10 to power minus 7 up? So this will become 3 upon 5, 10 to power of 15. So can I write down this thing as 30 upon 5, 10 to power of 14? Can I write that down? Okay, this will become 6. So answer will be frequency is equal to 6 into 10 to power of 14 hertz. Hertz or per second. Very good, bache. Very good. No, Satvik, you are almost correct. Preeti correct. Sriram correct. Very good. Sharanya correct. Arey wow, great, great. Vijay correct. Good. Kalam. Good. Sabka अच्छा रहा है. Good. Very good. Sheshagiri, it will be 6 into 10 to power of 14 hertz or per second. Will that do? Will that do? Okay. I want you guys, boys and girls, to find out the wave number of the same question. Find out the wave number. Come on now. Be quick. Find wave number. Bhai log 2.8 acha energy. No, I'll ask energy later on. First of all, I'll go with the wave number. Chalo. Wave number. Now wave number is equal to 1 upon lambda. 1 upon lambda. And lambda in meter is what? This one. So 1 upon 5 into 10 to power of minus 7. Yes or no? This can be written as 10 to power of 7 upon 5, which is also equal to 10 into 10 to power of 6 upon 5. Yes or no? Very good. Durga Prasad. Very, very good. Sriram also good. Manish very good. Vijay very good. Keep it up. Someone else was there. Tulsi very good. So maybe Tulsi is the first one to give the right answer. Okay, so here 2 into 10 to power of 6. What is that? What is the unit of this? Unit batao. Tell me unit. Since lambda is basically meter, it will be per meter. Per meter. Very good. Very, very good, Tulsi. Superb. Excellent. Brilliant. Bahut achhe. So I believe that if they give you anything, you will be able to calculate those questions. Yes or no? Now, shall we move to the questions of energy now? Okay, chalo, aaja. Per meter, it is per meter. Okay, good one. Very good. So, first question coming up. First question is that they're saying all about electromagnetic radiation. They're saying that lambda of a photon or a quantum is basically given as, say, 6000 angstrom. They're saying find the energy of that quantum or the photon. Find energy of the quantum and photon. Jaldi karo, be quick. Fastest fingers first. Jaldi karo, bachcho. Be quick. I know that E will be equal to what? Hc upon lambda. And lambda has to be in meter, because I'll be writing this as 2 into 10 to power of minus 25. Lambda will be, I believe, 6 into 10 to power minus 7 meter. Agree or not? Agree or not, everyone? Multiply this by 10 to power minus 10. So this will be lambda कितना आएगा? 6 into 10 to power of minus 7. This is minus 25. This is minus 25. And this will be gone 10 to power of minus 18. And if you allow me, can I write down 20 by 6 into 10 to power of minus 19? Yes or no? And if I'm not wrong, this will be 3.3 into 10 to power of minus 19 joule. 19 joule. This way, your energy will be in joule. 3 into 10 to power of 18. No, beta. Kavita, check it out. Vijay, check it out, beta. Please understand. 10 to power of minus and Ramaya Royal. See, never give the answers like 0.33 into 10 to the power minus 18. Please try to give the answer in scientific notation, which is like this format. Okay? This format, not 0.33. Okay? Is that okay now, Sriram? Sriram, यार बहुत डिस्टर्ब करता है तू यार. Is it okay or not? Okay or not? जल्दी बताओ. Sriram. अरे उधर आ रहा हूं. रुक तो सही. I'll come there. I mean, you can have different method also. You can have different method also. Which one? I mean, that asking energy. I'll give the energy in terms of electron volt. Then it will be like say 12400 upon lambda. In angstrom. So 12400 lambda is what? 6000. Hello? So can I go approximate? If you don't want Paramvir Chakra, you want Paramvir Chakra or MBBS degree? I believe we should be going for MBBS degree. This should be like 1200. Will it be okay? Will it be okay? And this will be 6000. Gone. 2. Approximately 2 electron volt. 2 electron volt. And they are asking the answer in what? Joule. They are asking the answer in joule. So energy will be what? 2 into 1.6 10 to the power minus 19 joule. Convert electron volt into joule. And that will be like 3.2 10 to the power of minus 19 joule. See that? They both are almost same. Almost same. They will never give you like say answers like 3.3, 3.2, 3.1, 3 point something. The paper will be formed by the Indians, not by Pakistanis. Unless a Pakistani is forming the paper, they will never give you these kind of options. Okay? So I told you give the answer in terms of joule. Why are you giving electron volt? Okay? Shall we? Come on. Okay, here we go. Question. One more question. Give me approximate answers. Give me approximate answers. I'm saying lambda of the photon is given as 250 nanometer. 250 nanometer. Find out energy. Come on. Find energy. You can now give me the first answer in electron volt and then in joule. First in electron volt, then in joule. Come on, be quick. Be quick. Nanometer. So I believe that E will be in electron volt equal to what? 1240 upon 250. Upon 250. And approximately, I can make it 1250 upon 250. Gone. Now 25 into 5 is 125. Approximately 5 electron volt. Very good. 4.95 एक ही बात है बच्चे, है ना? This is electron volt. Can you convert this into what? Joule? Convert this into joule. Come on, boys and girls. Right now, right here. So energy in joule will be like what? 5 into 1.6 10 to power of minus 19 joule. Which will be how much? This will become 8. 8 into 10 to power of minus 19 joule. And yes, Tulsi was the first one to answer that in terms of this one. Sriram, correct, very good. Manish, very good. Sajid, very good. Sriram, good, very good, very good. Kalam, also good. Chalo, ठीक है. Okay, no problem. So can we move ahead? Can we? Okay, now see that thing. One more question. Today is your birthday. So bhai, we are having Sunita is having the birthday today. Sunita Gudia, I wish you a very, very happy birthday. And on your birthday, I can just say that, Gudia, keep on working hard. Just don't give up. Keep on moving on the right track. And you will get whatever you want. Have some more patience, bache. I wish you a happy birthday. And maybe you are having all your wishes coming alive as soon as possible in the best ways as well. Wish you happy birthday, bachcho. So you are having the birthday wishes from the entire class. They're making your day right. Keep it up. Keep it up. Okay, chalo. The celebrations will keep on going, and let's solve one question right now. So first question out there is that we have got energy is given as 3 electron volt. For a photon, energy is 3 electron volt. Now find out the lambda. Come on, find out the lambda in angstrom. If energy is given as 3 electron volt, please find out lambda of that photon. Okay. सबने बना दिया birthday. So where is our party? We have given the wishes. Now we want party. Yes or no, boys and girls? We need party. But right now we want answer. We want answer. So I mean lambda will be, I mean you know that E is equal to 12400 upon lambda, which will be in angstrom. And if this is in electron volt, so lambda will be 12400 upon what? 3, which will be 4133.3 angstrom, or approximately 4000 angstrom. Approximately like that, na? So 4133 or 4100, one and same thing. One and same thing. Okay, that's done. Done. Great. Okay, now let's move and do one more question. Boys and girls, you remember that E is proportional to frequency, and which is inversely proportional to lambda. This we know now. This we know now. So from here, can I say that E1 upon E2 will be frequency 1 upon frequency 2? Yes or no? Or I can also say that E1 upon E2 will be equal to lambda 2 upon lambda 1. They both are inversely proportional. So we'll do a question on that stuff. We'll do a question on that. So will you agree with me if I say, beta, will you agree with me if I say that if energy is doubled, if energy of a photon is doubled, does it mean that the frequency will also be doubled? If energy is doubled, frequency will also be doubled. Because frequency and energy is directly proportional to frequency. Yes or no? Yes. Correct. Can I say that if energy is doubled, wavelength will become half? True or false? If energy is doubled, wavelength will be halved. True or false? It will be half. Very good. If energy is made 4 times, wavelength becomes 1/4. True or false? If energy becomes 4 times, wavelength becomes 1/4 times. Very good. But frequency will become 4 times. True or false? That is also true. Very good. So let's do a question now. And the question says that if lambda 1 is 3000 angstrom and lambda 2 is 6000 angstrom, you have to find out E2 by E1. You have to find out E2 by E1 ratio. Come on, find out E2 by E1. Be quick. Excellently quick. Come on. Will it be 1/2 or 2/1? I'm getting both answers on the screen right now. 1/2 or 2/1. Be very careful. I know that E2 by E1 will be from here. I mean, this is E1 by E2 equal lambda 2 by lambda 1. E2 by 1 will be lambda 1 by lambda 2. Lambda 1 is 3000 and lambda 2 is 6000 from here. This will be 1 by 2. So E2 by E1 is 1 by 2. Be careful because they will give you both the options, 1 by 2 as well as 2 is to 1. Okay, here we go. Be careful. Chalo, one question I'm giving you E1 is equal to E and E2 I'm giving you 4E. If lambda 1 is say 6000 angstrom, lambda 2 will be how much? Is there anyone who can give me verbal answer right now? Right now, verbal answer. So simple. It's a very simple question. Give me verbal right now. Use the logic, common sense. Very good, Srinu. Brilliant, Srinu. Brilliant. Very good. Very good. Rama Royal. Very good, bache. Very, very good. Rama Royal. Amina. Very good. Preeti. Very good. Sajid. Parvati. Sriram. Good. Very good. Sharanya. Something is wrong. Be careful. Srinivas. Puneet. Manish. Manisha. Sneha. Mithili. Hari sabka acha hai. Very good. Very, very good. So here what we have done, if energy has become 4 times, wavelength will become 1 by 4 times. Wavelength will become 1 by 4 times. We have just done right now. And 1 by 4th of 6000 is what? 1500. That's good. That's very good. Or if you are not comfortable with that, I can say that E1 upon E2 will be lambda 2 upon lambda 1. Or you can simply say that lambda 2 upon lambda 1 will be E1 upon E2. So what is E1? E1 is E and this is 4E. E and E cancels. So from here we can say that lambda 2 upon lambda 1 is equal to 1 by 4, or I can say lambda 2 will be equal to lambda 1 by 4 equal to 6000 by 4, which is equal to how much? Equal to 1500 angstrom. 1500 angstrom. Yes or no? Done, everyone? Great. Okay, chalo. Let's do few more questions. Okay, chalo batao. Find total energy of 1 mole of photons. Find total energy of 1 mole of photons. Find total energy of 1 mole of photons whose wavelength is 3000 angstrom. 3000 angstrom. You have to give the answer in joule. Give the answer in joule, boys and girls. Come on. Be very quick. Very quick. Lambda is equal to 3000 angstrom. Come on, be quick. Crack it. 1 mole. I believe that total energy is equal to NH nu. And here, but what is the value of N? Who will tell me what is the value of N? What is the value of N? How many photons are there in 1 mole? Avogadro number? Avogadro number into, this is what? Lambda. So Hc upon lambda. This will be Hc upon lambda. Yes or no? And if that is the case, I believe I can also write down total energy will be 6 into 10 to power of 23, while the value of Hc will be how much, beta? 2 into 10 to power of minus 25, which we have already done. And lambda will be how much, bacho? 3 into 10 to power of minus 7 meter. We'll need meter, bache. Okay, so 3 into 10 to power of minus 7. Solve it. This will be 10 to power of minus 18. Yes or no? And I believe 10 to power of minus 18 and 10 to power of 23, they will cancel to give you what? 10 to power of 5. And now 3 into 2. So 2 into 2 into 10 to power of 5, which will be equal to 4 into 10 to power of 5 joule. This much of energy will be carried by 1 mole of photons. By 1 mole of photons. How many got the right answer? I can see Durga Prasad got the right answer. Tulsi, Manisha, Dinesh, Amina, and Sai Krishna. Please write down in the scientific format. Sunita, very good, bache. On the birthday, you are doing too good. Keep it up. Keep it up. Satvik, very good. Puneet, good. Vijay, very good. Sriram, good. Devi, Surya, सबका आ रहा है यार. All of you getting that. हाँ, Mithili, beta, please make sure that you're writing in that format only. Mokshit Yadav, what is that? Something is wrong. Preeti Sharanya, Janvi, all of you correct. All of you correct. Excellent. Keep it up. So I'll give you one more question now. One more question, है ना? चलो बताओ. 3 into 10 to power of 18 photons. 3 into 10 to power of 18 photons have a total energy of 1.5 joule. Have a total energy of 1.5 joule. Find wavelength of photons. Find wavelength of photons. Find wavelength of photons. Be quick. Chali, be quick. Preeti, correct. Very good. Sriram, very good. Amina, beta, please check it out. Something has gone wrong. Manisha, very good. Good. देखो, see, I know that total energy is equal to N hc upon lambda. They're asking lambda. So total energy is 1.5 joule. N is given as these many photons. 3 into 10 to power of 18. And this is, as always, 2 into 10 to power of minus 25 upon lambda. Now this lambda will come in meter, beta. Lambda will come in meter. When you are using this value, your lambda will be always in meter. Good, bacho, very good. All of you are getting the right answer. Oh, brilliant class. Superb, great. So I believe that lambda will be 3 into 10 to power of 18 into 2 into 10 to power of minus 25 upon 1.5. So 1.5 and this will be 2 times. This will be gone and this will be 10 to power of minus 7. Now we have got 2 into 2. Amina, I think that you forgot this thing to multiply by 2. Hai na? 1 time, sir. 1 time means what? This will be 4 into 10 to power of minus 7 meter. Acha, can you give me the answer in angstrom? Can you give me the answer in angstrom? We have to convert that into angstrom. Tell me one thing. Is it correct answer? Is it correct answer? 4,000 angstrom. Yes or no? That's good. Correct. Absolutely correct. Okay. So we will do one last question. One last question is very, very important. I'm saying this very important question. And like the examiner will be asking you this question multiple times, till you are going for the NEET entrance examination. Please write down. Write down. A light bulb emits photons. A light bulb emits photons of lambda equal to 5,000 angstrom. A light bulb emits photons of lambda equal to 5,000 angstrom. Full stop. Full stop. The bulb is rated. The bulb is rated. The bulb is rated 150 watt. The bulb is rated 150 watt. 150. 150 watt. And only 8% and only 8% of energy, and only 8% of energy is emitted. Only 8% of energy is emitted in form of light. In form of light. Find number of photons of light emitted per second. Find number of photons of light emitted per second. It's a very important question. Very, very important. They'll ask you this way or that way. Find number of photons of light emitted per second. Now understand one thing. What is the meaning of 150 watt? Decode the question now. 150 watt actually means, beta, 150 joule per second. That means this bulb is giving 150 joule of energy per second. Yes or no? Yes or no, beta? That means 150 joule. And out of that, only 8% is coming as light. Only 8% is coming as light. Rest 92% is wasted. Rest 92% is wasted in form of what? Heat. So when you touch a bulb which has been lit for the past half an hour, you will see that it has become hot. It has become extremely hot. Yes or no? That means these bulbs which we are using in our house, they are not energy efficient. That's why they kept on developing LCD and then LED bulbs also. So amount of light energy will be 150 into 8 upon 100. This will be 12 joule. This is what total energy, light energy. Total light energy emitted per second is 12 joule. 12 joule per second. In 1 second, this much of energy is released. Now, if this is the total energy released, I believe total energy is equal to what? N Hc upon lambda. This is what? 12 joule equal to what? N into 2 into 10 to power of minus 25 upon lambda. Lambda is 5000 angstrom. Can I write down 5 into 10 to power of minus 7? In that case, N will be 12 into 5 into 10 to power of minus 7 upon what? 2 into 10 to power of minus 25. Some people have gotten the answer. Very, very good. Excellent. Sai Krishna, correct. Absolutely correct. Preeti, make it sure that you're writing in the scientific notation. Sunita, correct. Srinivas, Manisha, Dinesh, Srinu, Sajid, very good. Brilliant class. बहुत अच्छे. Amina, very good. Durga Prasad, very good. Ananya, very good. Very good. So I believe that this will be, my mistake. This will be 6 times and this will be 10 to power of 18. So this will be 6 into 5, 30. So 30 into 10 to power of 18 photons. In scientific notation, it will be 3 into 10 to power of 19 photons. These many photons will be emitted per second. Okay? So whenever you get this kind of question again, so where you will begin? You will first decode this 150 watt. They can give you other value also, but this is like say 150 joule per second. Out of that, 8% is light, rest 92% is wasted in the form of heat. So we will calculate the light energy out of 150 joule, which is 8%. How much it is coming? In this case, 12 joule. This is the total amount of light energy which is given per second. This is all per second. So number of photons given off per second will be what? N Hc upon lambda. This is 12. Put the values, you will get the value of N. Is that clear to all of you? So this will be your syllabus for the coming test. I wish you all the best. Please do practice questions. God bless you. Bye bye and take care. Bye bye. All the best. Bye bye.